The thing from the field, that gauge field,
Yeah.
is the electromagnetic 4 vector that becomes a photon.
Okay, now this is
getting crazy.
Yeah.
But like, imagine, it's completely inverting the logic of how you want to study the universe, right? Because it's saying we can take it as an axiom the fact that these symmetries exist,
Yes.
and then ask what is the kind of universe that we would live in if these symmetries exist. Right? We talked about how the wave function, right? It's a
Yes.
complex number.
Yes.
It's everywhere in space. If I change the phase of that wave function, that complex number, and the only thing I care about in terms of observables is the magnitude of that complex number, then it doesn't matter how much I change the phase.
Yes.
As long as I change the phase everywhere,
Yes.
the observable is going to be the same. That gives me conservation of charge. Okay.
Yes.
We can ask, what if I want to change the phase differently everywhere in space and time?
Yes.
Okay, so instead of a global symmetry, which
Yes.
is where I change the phase everywhere, I change the phase locally.
Yes.
Is there a local symmetry that I can do? Okay, if I change the local phase everywhere, then I can't really do a derivative in the right sense, right? Because the derivative, a spatial derivative in some sense, is the change between this quantity and this quantity. Well, if I change this guy and I don't change this guy, now my derivative is really not well defined. If I change them by the same amount, then that change cancels out and my derivative is fine. But if it's a local thing, then the derivative is no longer well defined.
Yes.
But what I can do is I can compensate for it. And it's kind of like, if every city had its own local currency and they just decided to change their currency denomination or whatever, you would need some way, some exchange rate to make sure that I'm still paying for the right amount of stuff.
Yes.
Right? That's where a gauge field comes in. To preserve the local symmetry where it's like, okay, I changed the phase here, but not here. What do I have to do to compensate for that, to make sure that all of my mathematics is still fine? I can still do a derivative. It's something that becomes like a covariant derivative. All of these things introduce the gauge field, which is a new entity. And the sole purpose of this field is to connect the different symmetry choices that I have in all of these different neighboring points. And it provides a rule on how to compare all of my different thingies. Right? It turns out that currency exchange is itself a field that is very, very much real, because that currency exchange has a certain value at each point, right?
Yes.
Depending on this city versus this city versus this city. So that field permeates space-time, and the real miracle of gauge theory is that that field is, when it's curved, when it like changes, that exerts a force, and that force is it can manifest in real things. For example, in the electromagnetic field, force is the electromagnetic force. That is the photon.